This video is going to explain how to write the sentences in the language of direct and inverse variation, and then from the equation, and then how to write the equation from the sentences so that you can use them in real life. And then we're going to do an application problem. So the first thing, we're going to write a complete sentence describing the relationship in the language of direct and inverse variation, including the constant of variation / proportionality. So what that means is that we have to say what varies and how it varies, and then with our constant. So if we look at this first example, we have to determine what type of variation it is to begin with. As long as one of your variables is completely alone, we can determine this. We have no addition, subtraction, so we have m varies, because it says m equals. So we got to see where the other variable is. We have one variable, we have n. N is on top, n is on the top, so this is a direct variation. And our constant, again, our top number is 3, our bottom number is 4. So our constant is 3 over 4. So all we have to do is just write this in a sentence. So we would say, since it is m equals, it would be m varies. M varies. We said direct, so it's directly with, and then it was with the other variable within. With a constant. With a constant of. And our k was 3/4, so we just say of 3/4. So again, our sentence is m varies directly within with a constant of 3/4. So m varies directly, so m equals k times n. And our constant is 3 over 4, so our k becomes a 3 over 4 with our n that's on the top with a 3. So that is correct. On number 2, we have one variable by itself, and we have no addition, subtraction, so that means we can determine this. Now, x varies is what it's going to say. Now, we have 3 different variables going on here. So we have to talk about p, r, and y. So if you notice, the p and r are both on the top. So this p and r are both direct variations. So we would say direct with p and r. But then y is on the bottom, so that's an inverse. So we would say inverse with y. We also need to find our constant. So we can go ahead and put k equals. Our top number is 1. Our bottom number is 7. So k is equal to 1 over 7. Gotta be careful about that k. Now all we have to do is just write this in a sentence. We have the pieces, now just writing a complete sentence. X equals means x varies. So x varies. We start off with p and r, so directly with p and r. Okay? But then and inversely. So we say and inversely with y. We don't have to say varies again because we already said x varies. That means x is equal to all of this. Okay? So we would have x equals k times p times r. Inversely is divided by y. But then we know what our k is, so we would say with a constant of. With a constant of 1 over 7. So that means that on the top we'd have a 1 and on the bottom we'd have the 7 with the letters that we have with it. So that's where that comes from. So we'd have a 1 on top and then a 7 on the bottom. You only have to have one division bar. You don't have to keep making more divisions because once you have one division, you can just keep putting things on top or bottom. That's how you write a complete sentence. Now, we're going to write the equation represented by the information in the following sentences. So this goes back to real world. So you can actually use this in real world application problems. So it says the sales tax T is directly proportional to the purchase price P with constant variation of 6/100. So it says the sales tax T is directly proportional. It doesn't say the word varies, but it says directly proportional. Now variation and proportionality are the same thing. So directly proportional to the purchase price P. So T is what we would do here is we would put T is, so T equals. K. We always have to have our K next. So our constant is the 600ths, so 0.06, so 600ths. And then it says directly, since it says directly, so T is, and it says directly proportional, that means a multiplication. So we will do 600ths times the P. So 600ths P. And there's your equation. On number 4, it says cost per person C varies inversely with number of members N with constant proportionality 225. So it says varies inversely. So the cost per person is what varies. So C varies. C varies. And then it says inversely. So C equals. It says inversely, so we're going to have our K. We always have to have our K next. Our constant is 225. So we have 225. And then it says inversely is division. So what are we dividing by? With the number of members N. So we'd have C equals 225 over N. That's all that is. There's your equation. And then we can find any answer we need to. Example 5 says the average speed for the Daytona 500 race is inversely proportional to the time it takes to complete the race. Now there are no variables here to use, so we have to use our own. And we want to make them make sense. We're not just going to use X and Y because those are variables. It says the average speed for the Daytona 500 race is inversely proportional. So the average speed. So I would probably go with S for speed. So the average speed is. Speed is. And then it says inversely proportional. And it says to the time it takes to complete the race. So time it takes, to the time. I would use T for time. T for time. Now we need to know our constant. Now the constant in here, if we think about the Daytona 500 race, that's 500 miles. Every car has to go 500 miles. And actually at the Daytona 500, the track is 2 miles long, so they actually do 250 laps, but they all have to go 500 miles. So that is your constant. The 500 is what your constant is. Even though it doesn't say the constant is 500, we have to understand what we're given. So every car at the Daytona 500 has to drive the 500 miles. So that's why that's your constant, because it's constant for everyone. So we would write speed is. So speed is. So S equals. We go ahead and write our 500, because that's our K. It says inversely. That's division. And then divide by T. So then the faster you go, the less time it'll take. The less time it takes, the faster you win. Okay? And so if you think about that, if you go slower, it's going to take you more time. Remember how we talked about if it was one variable goes up, the other variable goes down is inverse? So as speed goes up, as you go faster, time goes down. So that's an inverse. On number 6, it says force F varies jointly with pressure P and mass M and inversely with time T. Okay, so we have a lot of different variables going on, but nowhere in here does it say what our constant is. So since we don't know what our constant is, we can't put a constant. So that means we have to put K. So our constant on this one is K. Constant is K, because we don't actually know it. So we started off with, it says force F varies. So we know this is what we want, force varies, so F equals. Now the constant is K, so go ahead and put our K. Jointly with pressure P and mass M. So pressure P and mass M jointly means a bunch of multiplication. So it's really just P times M. That's K times P times M. But then it says, and inversely with time T. So inversely means we're going to divide. Now again, we don't have to rewrite anything else. We just go ahead and put division on here and put our T in the denominator. and that's our equation. Because we don't know the constant, but if we knew the constant, we would put that where the k is. This last problem is we're given the equation and we're going to answer the following questions. This is actually a conversion between inches and centimeters. In order to convert from inches to centimeters, we have to divide by 2.54, or 2 and 54 hundredths. This is how many centimeters are in 1 inch. And if you know anything about converting, the smaller unit actually has the bigger number. If you think about feet and inches, a foot is only 1 foot versus an inch is 12 inches. So the smaller unit, inches, had the bigger number. So the first question is this function an example of direct variation, inverse variation, or neither, and explain. Okay, so first we have to look at, is one of the variables completely alone? It is. And then where is your c located? The c is actually in the top. That means it's going to be a direct variation. But we can also think about this as, if we have more inches, if we're measuring something that has more inches, that means there will also be more centimeters. So as the inches increase, the centimeters will also increase. So that's the direct variation anyway. But because of the variable is on top, so that means it's going to be a direct variation. So it's direct variation. And one reason is the variable is on top. And we can also say as inches increase, centimeters increase. Because as one variable goes up, the other variable goes up. Then it asks, what is the constant of variation or proportionality? Since it's in the correct format, our constant equals, our top number is 1, our bottom number is 2 and 54 hundredths. So our constant is 1 over 2 and 54 hundredths. Now it's asking us if c is 150, find the value of I. What that just means is we're going to plug that into our equation. So we have c, so we're going to plug c in, we don't have I. So I equals 150 divided by 2 and 54 hundredths. So 150 divided by 2 and 54 hundredths is 59 and I'll say 6 hundredths. So let's just round to the nearest hundredth. So the inches, if you have 150 centimeters, you actually have 59 and 6 hundredths inches. So again, you have more centimeters than you do inches. The smaller the unit, the bigger the number. Centimeters is 150, inches is a bigger unit, it's a smaller number. On part 4, it says if I equals 67, find the value of c. So again, we're going to plug it into the equation. I is 67 equals c over 2 and 54 hundredths. So again, if the inches is a bigger unit, has a smaller number, we're actually going to get an even bigger number for our centimeters. So in order to do this, we would just multiply by 2 and 54 hundredths. So when we multiply this, we would get centimeters is equal to 170 and 18 hundredths centimeters. That's bigger. It's a smaller unit, so it has to be a bigger number. That's just plugging the numbers into the equation. If you're given the equation, just plug the numbers in and solve. This last part says express the original equation, in a different but equivalent symbolic form. A different but equivalent symbolic form, if I go back to my original notes, it says to get k alone. We actually want to get k, our constant, alone. So our constant was 1 and 2 and 54 hundredths. That's what we want. So we actually have to get 1 and over 254 hundredths equal to something. That's what we have to do. So we have our equation. I equals c over 2 and 54 hundredths. Well, the first thing that we can do is get rid of the 2 and 54 hundredths off of the denominator so we can make it go to the left by multiplying by 2 and 54 hundredths on both sides. That will get rid of it from the right hand side. So we'll have a little arrow. This is 2 and 54 hundredths I equals c. Now we want to get the 2 and 54 hundredths alone, but again, we want to make it end up looking like this. So the first thing we need to do is at least divide by that I. We want to divide by that I so we can get the 2 5400ths along. So divide both sides by I. We end up getting 2 5400ths equals C over I. Now we're almost there. We need to make the 2 5400ths be under 1. So if I do this same thing to both sides, as long as I manipulate the problem and not change the value of it, I'll be okay. So in order for me to get the 1 over 2 5400ths, if I were to, because it's technically over 1 right now, if I were to flip these, and as long as I flip these as well, do the reciprocals of those, then I'll keep it in the same value. So then what I'll have is 1 over 2 5400ths is equal to I over C. I got that 1 over 2 5400ths is equal to I over C. And this is our final answer. So we wanted to get K alone. So again, this was writing the sentences. So knowing how to write the sentences from the equation. Writing the equation from the sentences and finding your constant, even if it doesn't tell you the constant, you can determine it. Or if it doesn't tell you at all, then you know your constant is just going to be K. You're just going to put the letter K. And then you're going to actually know how to use the equation to answer specific questions.